Now, as a final example, read in the milk data set. So let's open that up. So this gives the monthly milk production in pounds per cow for looks like January 1962 through December 1975. So let's convert that to a time series. And again, we have 12 points per year, so frequency equals 12, and the start date is January 1962. Hit enter, and let's create a plot here. So, this series has a strong trend upwards, right? Milk production seems to be increasing. There's also a definite cyclical component, right? You can see this repeating pattern very clearly year by year. So, in this case, it might be effective to use a Holt-Winters model to fit your data. So, we're essentially just going to repeat the analysis from before, but we're going to fit a Holt-Winters model. So, let's create an object called milk forecasts. And now we're going to type Holt-Winters. But none of the parameters are going to be set to false because we'll have the alpha, and then we'll have the beta for the trend, and also the gamma parameter for the seasonality. So we just type our time series object here and take a look. And you can see our components here, the alpha, beta, and gamma. So let's extract our forecast values. So let's call them milk forecast values. And that gets the value milk forecasts. Remember, we're selecting that first column of the fitted component. Hit enter. And you've extracted the milk forecast values, right? So that's a time series with 156 entries. If you wanted to calculate the mean square error, you would simply define the errors squared. So remember, that's the difference between the time series and your forecast values squared. Then if you take sum of those errors, which is so the sum of the errors squared divided by 156, which is the number of values. Remember, that's the mean square error, the sum of your squared errors divided by the number of values. And you get 67.53. So we can plot our forecasts. And you can see in this case, because the time series is so regular, right, the trend is fairly strong and the seasonal pattern is repeats quite predictably, your model in this case fits the time series very closely. And so if you wanted to extract, your forecasted value, you would just take the forecast values and extract the last component, because that gives you the prediction for the next period, and you get 840.4. So the prediction is that in 1976, January 1976, the monthly milk production for cows would be estimated to be about 840.4 pounds. Now, if you wanted to forecast further into the future, well, we'd use that forecast package. But actually, first, let me just extract that sum of the squared errors. And remember, if we divide that by 156, we should get the same mean square error we got before, just to double check. And I selected something wrong. Oh, wrong object. This sum of squared errors is a component just of that milk forecasts object, your Holt-Winters model. Hit enter and you get, right, 67.53, which we calculated before. So that looks good. Okay, so let's use that forecast package to predict a few more periods into the future. So let's go Holt-Winters forecasts, get the value of forecast, of our fitted model, milk forecasts, and let's let's try 10 periods into the future. Let's take a look. We'll print that, and now you can see your predicted milk production in pounds per cow from January to October of 1976. If you wanted to plot that, we'll take a look here. You can see in this case your forecasted values are given in this blue line, and you can see the confidence bounds in this case are fairly close to the blue line, right? There's not a lot of deviation. So in this case, because the time series is pretty regular and the Holt-Winters does a really good job of fitting the model to the data, you actually have a pretty good forecast. And in this case, it'd probably be reasonable to predict more than 1 or 2 periods into the future with some amount of accuracy. Whereas in other models, it's a little bit more difficult because it can be a bit more tricky to fit the data. So we've covered simple exponential smoothing, Holt exponential smoothing, and then Holt-Winters exponential smoothing. And that concludes the lessons on time series analysis.